Imagine network switches.
Mm,
You know, the ones that direct all the traffic on the internet.
yeah,
Like they're getting like a major brain boost.
right.
That's that's kind of the potential of SONiC,
Mm-hmm.
this open source network operating system,
Yeah,
especially when we think about all this buzz about AI agents.
yeah.
So today we're going to dive into SONiC,
Okay.
see how it actually works, and then explore this really fascinating world of AI agents.
It's good.
Specifically, we'll be looking at a new framework from Hugging Face called Small Agents.
Oh, yeah, I've heard about that.
Yeah, and what's really interesting is how these two seemingly totally separate worlds
Right.
are starting to kind of converge and come together.
Quickly, yeah. It's like we're seeing this big shift from these like static, vendor-locked systems
Yeah.
to a much more dynamic and intelligent way of handling networks.
Yeah.
And Sonic being open source means it can evolve way faster.
Right.
You've got this whole community of developers behind it, constantly improving it.
Yeah.
And then you bring AI agents into the mix. Right.
And you've got the potential for like crazy automation and adaptability that could totally revolutionize how we manage networks.
Yeah, that's really exciting.
Definitely.
So let's start with Sonic.
Okay.
It's basically like the brains of a network switch.
Right.
But unlike traditional systems, it's open source.
Yeah.
So instead of being stuck with whatever software the vendor gives you,
Right.
data centers using Sonic, they have like the freedom to customize and control their network infrastructure.
Exactly.
Yeah.
It's a huge advantage, especially now when data centers are constantly changing and growing.
Right.
Sonic's open source nature lets it keep up with that pace of innovation.
Yeah.
It avoids the limitations of being locked into one vendor.
Yeah.
So you're not stuck with just one hardware vendor
Yeah.
or waiting on their software updates.
Right. You have so much more control.
Exactly.
So let's take a peek under the hood of Sonic.
Yeah, let's do it.
So it uses this really cool modular architecture
Yeah.
that's built around Docker containers.
Think of those like individual software packages,
Got it.
each one handling like a specific networking function.
Okay. Makes sense.
Yeah. And all these containers, they talk to each other
Yeah. How do they do that?
through a central Redis database.
Okay.
It acts kind of like a central hub
Right.
where all the different modules can like share information and coordinate their actions.
Okay. So they're all working together.
Yeah, and this makes the system super flexible and adaptable
Mm-hmm.
because you can like add or remove functionality
Yeah.
just by plugging in or unplugging containers.
Cool, like Lego blocks for your network.
Exactly like Lego blocks.
Right, I like that.
So we have all these containers doing their own thing.
Yeah.
But how does this actually work in like a real network scenario?
Right. Good question.
Like what happens when something changes?
Well, let's look at an example.
Okay.
Say a new route gets announced from an external BGP peer.
Okay.
Now, BGP, that's Border Gateway Protocol.
Right.
It's basically how different networks talk to each other and share routing information.
Okay. So like a global map of the internet.
Exactly, like a giant map.
So a new route pops up.
Yep, and that triggers a whole chain reaction inside Sonic.
Okay. So walk me through it.
All right, so this new route information, it comes in.
Yeah.
And the BGP container grabs it, and then it notifies this module called Zebra.
Zebra.
Yeah, Zebra is like the central routing manager.
Got it.
So Zebra checks out this new route, makes sure it's actually reachable.
Makes sense.
If everything looks good, Zebra updates the kernel's routing table.
Okay.
And that basically tells the whole system how to get to this new destination.
So it's like Zebra's in charge of making sure all the directions are correct.
Yeah, exactly.
Sounds like a lot of steps.
It might seem complicated, but that's actually what makes Sonic so powerful.
Okay. How so?
Well, it's a testament to its modular design.
Yeah.
Every component has a specific job, and they all work together seamlessly
Right.
to make sure the network is running smoothly.
Yeah.
This kind of granularity actually makes the system more robust and easier to fix when something goes wrong.
Oh, okay. So unlike those old school systems where everything's all tangled up,
Right.
Sonic's modularity lets you pinpoint issues way easier.
Exactly. It's much cleaner.
That makes a lot of sense.
Yeah.
Okay, so now let's switch gears a little bit.
All right.
Let's dive into this world of AI agents.
Okay.
Remember we mentioned small agents earlier?
Yeah, the framework from Hugging Face.
Right. What makes this one stand out from the crowd?
Well, the cool thing about small agents is that it learns from all the other AI agent frameworks that came before it.
Yeah.
They've taken all the best ideas and made a design that's both powerful and easy to use.
Okay, so it's like they've streamlined the whole process.
Exactly.
Made AI agents more accessible.
Yeah, definitely more user-friendly.
So what are some of the key features that make it so powerful?
One of the big ones is dynamic tool integration.
Okay.
Before, trying to integrate different tools and services with AI agents was a huge pain.
I bet.
But with small agents, it's super easy to plug in different tools.
Hmm.
So developers have way more flexibility to build agents that are tailor-made for specific tasks.
So it's like giving your AI agent a toolbox
Yeah,
that you can constantly expand with new tools and capabilities.
exactly. And speaking of specific capabilities,
Yeah?
small agents comes with two main agent types.
Okay, let's hear about those.
All right, so you've got code agents and tool calling agents.
Okay. Break those down for me. What's the difference?
Well, code agents, those are the real showstoppers.
Okay.
They can actually generate and execute Python code snippets.
Oh, wow.
Yeah, so they can tap into this massive ecosystem of Python libraries and tools.
So it's like giving them a deep understanding of one of the most popular programming languages out there.
Precisely.
That's incredible. The possibilities are endless.
Right. They can do complex calculations, analyze data, even control hardware directly.
Whoa.
Yeah, it's pretty powerful stuff.
Okay, so what about these tool calling agents? What are they good at?
Tool calling agents are more specialized in talking to structured systems. They're really good at making JSON-based tool calls, which is like the standard way to talk to APIs, databases, and other web services.
So they're the ones going out and fetching information
Yeah,
and
exactly.
interacting with external systems.
Yeah.
Maybe even automating those complicated workflows.
Right. They're great for that kind of stuff.
Okay, I'm starting to see how these different agent types
Yeah.
could be really powerful for managing and optimizing networks.
Yeah, absolutely.
So we have SONiC, this open and modular network operating system,
Right.
and then we have these super adaptable AI agents. Seems like there's a ton of potential for them to work together.
Huge potential.
But where exactly do these two worlds intersect?
That's the million-dollar question, isn't it?
It is.
The synergy between SONiC's open architecture and the flexibility of small agents is mind-blowing.
Yeah.
Imagine AI agents that can watch network traffic in real time,
Okay.
identify bottlenecks,
Yeah.
and then automatically adjust configurations to make everything run faster.
That sounds incredible.
Yeah. It's pretty amazing stuff.
But how would that actually work within SONiC's architecture?
Well, that's what we're going to talk about next time.
Okay.
We'll dig deeper into how AI agents can be integrated into SONiC and the specific ways they can revolutionize network management.
I'm excited for that.
It's going to be good.
So we talked about this potential synergy between SONiC and AI agents.
Right. They could be a real power couple.
Yeah, exactly. So now let's actually get into how this could work.
Okay, sounds good.
Last time we left off with this idea of AI agents monitoring network traffic and optimizing performance.
Right, making the network smarter.
Yeah, in real time.
Yeah.
So how would that actually play out, like, within SONiC's architecture?
Okay, so remember how SONiC uses those Docker containers for different functions?
Yeah, like those little Lego blocks.
Right, and the Redis database for communication?
Yep, it's like the central hub.
Exactly. So you could actually deploy an AI agent as a Docker container right inside that SONiC environment.
Oh, wow. So it's like plugging in another Lego block.
Exactly, and it would have access to all the data flowing through the Redis database.
Just like any other module.
Exactly, it's like part of the team.
So it's like plugging in another piece of the puzzle,
Yeah.
but this piece has like serious artificial intelligence behind it.
Yeah, it's a smart Lego block.
I like that. So what kind of AI agent are we talking about here?
Well, a code agent would be perfect for this scenario.
Okay, why is that?
It could tap into the Counter SDB?
Counter SDB?
Yeah, that's the database that stores all the performance metrics for every port in the system.
Okay, so it's like keeping tabs on how everything's performing.
Exactly. And it could use Python libraries to analyze all that data.
To find patterns?
Yep, and identify potential bottlenecks.
So if one port's getting slammed with traffic, the agent would see that.
Immediately, yep, and then it could do something about it.
What do you mean, like, could it actually fix the problem on its own?
Potentially, yeah. It could adjust the quality of service settings
Okay.
to prioritize traffic on the most important ports.
Right, so the critical stuff gets through.
Exactly. Or it could even reroute traffic to less congested paths.
Oh, wow. So it's like directing traffic around a jam.
Exactly.
Yeah.
And that's where the power of AI really shines.
How so?
It can react to these changing conditions so much faster than a human ever could.
Yeah, that makes sense. It's like having an intelligent traffic cop directing all the data through the network,
That's a great way to put it.
making sure everything runs smoothly.
Exactly. Keeping things flowing.
So we can take this even further, right?
Oh, yeah, we're just getting started.
Okay, so imagine a tool calling agent that talks directly to the ACCDB.
The ACCDB.
Yeah, the database that communicates with the ASICs, those specialized chips that handle the actual data switching.
Right, the hardware side of things.
Exactly.
Hmm.
So this agent would be more focused on the hardware,
Yeah, it would be like the hardware whisperer.
so it could keep an eye on the health of the network hardware.
Constantly, yeah, monitoring everything.
And if it sees an issue with a particular ASIC,
It could jump into action.
what would it do?
It could log the event, generate a support ticket, even try to restart the affected component.
Well, giving an AI agent that much access to critical hardware sounds kind of risky.
That's a valid concern. We definitely don't want things going haywire.
Right.
But there are ways to manage those risks.
Okay, how so?
We can use something called restricted imports for code agents.
Restricted imports? What's that?
It's like setting boundaries for the agent.
Okay.
It limits which Python libraries and functions it can use.
So it can't just go rogue and start messing things up.
Exactly. It's
Yeah.
all about keeping things safe and controlled.
And what about those tool calling agents?
For those, we can set up really strict access control policies
That's
on
like-
the APIs and databases they can talk to.
So it's like giving them a security badge.
Yeah, exactly. They can only go to certain areas.
That makes sense.
Mhm.
But even with all those precautions, couldn't the agent itself still be hacked?
Right? That's a good
Wow.
point. We have to remember security is a multi-layered thing. We need to treat these AI agents like critical parts of our infrastructure and protect them accordingly.
So it's not just about protecting the network from the agent,
Right.
but also protecting the agent from outside threats.
Exactly. It's a two-way street.
Okay, so we've got AI agents analyzing data, interacting with hardware, and we're thinking about security, but what about us humans?
Right. The network administrator.
Yeah, where do we fit into this whole AI-driven future?
That's a great question. And here's the thing. AI agents aren't meant to replace network administrators.
Okay, so they're not taking our job.
Not at all. They're here to help us to make our lives easier.
Okay, so how would that work in practice?
Imagine this, you're a network administrator and you keep seeing this weird network anomaly popping up.
Okay.
You can actually teach an AI agent to recognize that pattern.
Oh, wow. So it's like training a digital watchdog.
Exactly. And from that point on, the agent can monitor the entire network for that specific issue.
So it's constantly on the lookout.
Yep. And if it sees anything suspicious, it alerts you immediately.
So that frees up the administrator to focus on other stuff.
Right, the bigger picture stuff, strategy, problem solving, making sure the whole network is healthy.
It's like a partnership.
Exactly. Humans and AI working together.
So this idea of agent adaptability is really interesting.
It's crucial, especially as networks become more complex.
Yes, they need to be able to keep up.
And that's where AI really shines.
Okay, how so?
AI agents can adapt to changing conditions and learn from new data. It's like a constant feedback loop.
So we teach them and they learn.
Exactly. We provide the guidance and expertise, and the AI agents become more and more effective.
Okay, so we've covered a lot of ground here.
Yeah.
We've talked about integrating AI agents into SONiC, the potential benefits, the
Yeah.
security stuff. But let's get even more specific. How could AI agents improve different aspects of network management within SONiC? Like, where would we see the biggest impact? So we've talked about AI agents being like these intelligent assistants,
Okay.
helping out with things like troubleshooting and security.
Uh-huh.
But let's like zoom in on one of the biggest headaches for data centers.
Okay.
Resource allocation.
Yeah.
How can AI agents help us solve that puzzle inside a SONiC environment?
Well, resource allocation, it's all about making sure the right applications and services
Right.
are getting the bandwidth they need at the right time.
Yeah.
It's a constant balancing act, and trying to do it manually can be a real nightmare.
Especially in like a huge data center with tons of traffic flowing in and out.
Yeah,
It's like trying to direct rush hour traffic with no traffic lights.
that's a perfect analogy.
Right.
And that's where AI agents can come in,
Okay.
like our intelligent traffic management system.
Okay, I like that.
So picture an AI agent that's constantly looking at network traffic patterns
Yeah.
and resource utilization across the whole SONiC environment.
So it's got like its finger on the pulse of the whole network.
Exactly. It sees where the traffic's going and where the bottlenecks are.
Okay, so what does it do with all that information?
It can use that real-time data to dynamically adjust bandwidth allocation.
So if a critical application needs more bandwidth.
The agent makes sure it gets priority.
Okay.
And at the same time, it can stop less demanding services from hogging resources.
So it's like having a smart system that's constantly optimizing the flow of traffic,
Right.
making sure everything's running smoothly and efficiently.
Exactly. And that can lead to some serious cost savings for data center operators.
How so?
Well, they can avoid over-provisioning.
Over-provisioning.
That's where you allocate way more resources than you actually need just to be safe.
Well, just in case.
But with AI agents handling resource allocation,
Yeah,
they can use their infrastructure way more efficiently.
that's awesome.
Yeah, it's a win-win.
Okay, so we've tackled resource allocation. What about another pain point for network admins?
What's that?
Troubleshooting.
Yes.
I've heard stories about spending hours, even days,
Oh, yeah.
trying to track down the root cause of a network issue,
It can be like searching for a needle in a haystack.
especially in a complex data center.
Yeah, with so many moving parts.
But AI agents could be the metal detectors that make that search a lot easier.
Exactly. They can cut through the noise.
So how would that work? Would the agent just, like, tell us what's wrong?
It could do even more than that.
Okay.
It could analyze log files, monitor network traffic, even run diagnostic tests.
To really pinpoint the problem.
Exactly. And remember, an AI agent can process massive amounts of data way faster than a human.
It's like having a digital detective
Yeah.
that can sift through all the clues and say, hey, look here.
Exactly. It can point you in the right direction.
And could it ever, like, fix the problem itself?
In some cases, yeah.
Wow.
Like, let's say a service crashes.
Yeah.
The agent could see that happen and automatically restart the service.
Minimizing downtime.
Exactly. Keeping things running smoothly.
That would be a huge time saver for admins.
Yeah. No more late night calls because a server went down.
That's the dream.
Right.
But what about preventing those issues from happening in the first place?
That's where predictive maintenance comes in. AI agents can analyze all sorts of metrics.
Like what?
Things like temperature fan speeds, error rates.
Okay.
To spot potential hardware failures before they become a big problem.
So it's like having a virtual mechanic
Yeah.
that's constantly checking the health of your network equipment.
Exactly. And giving you a heads up if something looks like it's about to break down.
That's awesome.
Yeah, with that kind of early warning.
Data center operators can stay ahead of the game.
Right. They can replace failing components before they cause any major disruption.
So we've explored how AI agents could really change the game
Yeah.
for resource allocation, troubleshooting, even predicting hardware failures, all within SONiC.
It's pretty amazing stuff.
It really is. So what does all this mean for the future of networking?
I think it points to a fundamental shift in how we think about network management.
Okay.
We're moving towards networks that are self-aware,
Yeah,
self-healing, and constantly adapting to change.
that sounds pretty futuristic.
It does, and AI is going to play a key role in making that happen.
Not replacing human expertise, though, right?
Right. It's about empowering us
Giving us better tools.
to build more resilient and efficient networks.
It's an exciting future,
It is.
but also one that comes with big questions.
Yeah, for sure.
As AI agents become more embedded in our critical infrastructure, we have to be really thoughtful about security ethics and the role of human oversight.
Absolutely. We need to make sure these AI agents remain tools that we control,
All right,
not autonomous systems that are operating outside our understanding.
it's a conversation that needs to keep happening.
Definitely as this technology continues to evolve.
So as we wrap up this deep dive into SONiC and AI agents,
Yeah.
here's a final thought for you to ponder.
Yeah, hit me.
Could we reach a point where AI agents aren't just managing the network,
Yeah.
but actually designing and optimizing it themselves?
Wow.
Like, could we see AI agents that can autonomously configure new network topologies, select the best hardware,
Yeah.
write their own network protocol?
That's some next level stuff.
Right. It's a question that blurs the line between science fiction and a reality that's coming at us pretty fast.
Yeah. Makes you think.
We encourage you to check out the SONiC Wiki and the Small Agents documentation.
Definitely good resources.
And let us know what excites you the most about all this.
Yeah, we want to hear from you.
This is just the beginning of a very interesting conversation.
Absolutely. There's so much more to explore.